This is the second test for limits, continuity, and derivatives. I uploaded the other test review for the same topic. So if you want to study, you can go ahead and look at the other one too. Number one, limit x approaches -1 from negative side. What is your f of x approaches? So -1 is right here. So it's from negative side, it's approached to right here. So your answer should be then 2. Okay, so this is a 2. Now, when x approaches -1 from positive side, so you follow this line then. Okay, so that means answer is 2. Oh, the other one is a -2 though, by the way. So this is 2. So this is a -2. Now, when x approaches -1, then both limit it doesn't match. That means you have to say it does not exist. Okay. Now number 4, limit x approaches to 2 from positive side. So you follow this line here. So that means you approach to 0 here, right? Y value is a 0. Next one, when x approaches to 2 from left hand side, then you follow this. So then your y value is a 2. Now since right hand side limit, left hand side limit 4 and 5 doesn't match, so you have to say also does not exist. Okay. Number 7, when x approaches to 0, then when x approaches to 0, right here, it approaches to both right here, so that means it approaches to 2. Okay, so answer this one should be just 2. Number 9, what kind of discontinuity does f exhibit at x equals 2? So as you see here, so we call this one jump discontinuity. Okay, so jump discontinuity. Also that belongs to non-removable discontinuity. Okay, how are you gonna justify your answer? You can justify from the limit when x approaches to 2 left hand side f of x, then that is a 2, right here. And then limit x approaches to 2 from positive side f of x, then it approaches right here, which is a 0. If they don't match, then it's a jump discontinuity. Okay, non-removable. Number 10, limit x approaches to 2 from negative side, left hand side, and then it's 1. And limit x approaches to 2 from positive side is 3, and f of 2 is 3. So A, sketch the graph. So you can, a lot of answers are possible, but one possible answer, when x is a 2, 1, 2, 3, right here, that's the point for this. But left hand side limit is 1, so you can say like that. Okay. From the positive side, it approaches to 3, so you can say like this. Okay. So that's the sketch for answer A. Now, what kind of discontinuity does f exhibit at x equals 2? So this is also jump discontinuity, or you can say non-removable discontinuity. Justify, you can do same way. X approaches to 2, negative side, your f of x is 1, which is not equal to limit x approaches to 2 from the positive side f of x, that is a 3. Okay, that justifies there is a jump discontinuity at x equals 2. Now, next one, number 11, let's do one more here. So he said, when x approaches negative, so 1, 2, 3, -3 here. Left hand side limit 5, 1, 2, 3, 4, 5. So you can say like here, like that. Now, when x approaches to from positive side to -3, then also 5. So you can say like this, right? So that left hand side limit approaches to 5, and the right hand side limit also 5. But this one g of -3 is undefined. So I didn't filled in this one here, so there's a hole, then that's undefined. Okay, that's a one possible sketch. So that is answer. Now, what kind of discontinuity? This is a hole, right? Hole. So that we call removable. Only hole is removable. Removable discontinuity. How you gonna justify? Then you will see limit value is the same. So x approaches to -3 from negative side. Your g of x, that is a 5. That's gonna be equal to now limit x approaches to -3 from positive side g of x. That's also 5. So as long as they are same, that means their limit value exists. Then it's removable because it is a whole. Okay. Now next, find each limit. Show necessary work. So this is like a horizontal asymptote. Horizontal asymptote, you have a 3 scenario. Number 1, let's say denominator and numerator, they have the same power, like here. Then y equals coefficient. Okay, so coefficient of the highest power term. So in this case, right here, right? So that's a 2/4, 1/2. So you're in this case, your horizontal asymptote y equals 1/2. Okay, that's how you're gonna find out. So same as just limit x approaches to infinite. Second, horizontal asymptote, if a denominator higher power, then always y equals 0. The value will be 0. That's the reason. Number 3, if a numerator greater power, then no horizontal asymptote. So that means it equals infinite. Okay, so then this one is basically no horizontal asymptote. Okay, so let's look at here. Also, you can, one way you can also prove it, you divide by x squared algebraically. If your teacher asks you prove it algebraically, then you do this way. So when you divide it, limit x approaches to infinite, 2 plus 3/x minus 2/x squared all over 4, right? I divide by x squared, top and bottom. And then since x goes infinite, 3/infinite goes 0. 2/infinite equals 0, right? So then answer is 2/4, 1/2. Okay, you can prove it like that. So this one, if a denominator higher power right here, in this case, then always a 0. So answer, we know that's 0. But how you gonna prove it? You can prove this way. You divide by x squared top and bottom. Okay, then what happens is a limit x approaches infinite, 2 plus 3/x minus 2/x squared all over x minus 2. Okay, and then x goes infinite. So this one goes 0, this one goes 0. Any constant over infinite is 0. Now this one equals infinite, right? Minus 2 doesn't do anything. So basically 2/infinite, that means it equals 0. Okay, so you can prove it like that algebraically. Now let's move on. Number 14, each function find the limit x approaches to the given x value. They say like that, showing proper notation. Then determine if f of x is continuous at the given x value. If it's not continuous, then state type of discontinuity. Is it removable or non-removable? Is it whole or jump or infinite discontinuity? Okay, if it's a vertical asymptote, that's the infinite discontinuity, and justify your answer. Okay, let's do that then. First step, always you factor out as much as you can. So x plus 2, x plus 1 over x plus 2. And then you see that you have here same vector. That means that's a whole. So so this one you can say there's a whole, and then not continuous, right? So this is a not continuous at x equals -2 because the graph has a whole at x equals 2, negative 2. Okay, what kind of discontinuity? This one is removable. Okay, removable discontinuity. Okay, that's how I'm gonna say that. Now, B, when you factor this one, hold on, you don't have to factor. When you plug in 0, see what happened then. So f of 0 is basically 6 over 2, so which is 3. Okay, so it's defined. So, and then numerator and denominator both are polynomial, so there's no discontinuity. But you do have a vertical asymptote at x equals to negative 2, but that's not our interest. Only you're interested at x equals 0. So it is continuous. You have to say the function is continuous at x equals 0. Okay, that should be the answer. Because that x value we are interested in. Okay, next one, C. Our interest is at x equals 2. So let's do that. Limit x equals to 2 from negative side. That means 2x plus 3 there. So when you plug in 2 there, so 7. Now, limit x equals to 2 from positive side, x squared minus x. Then when you substitute 2, 4 minus 2 is a 2. And then you see that left-hand side limit, right-hand side limit is different. So that is what we call jump discontinuity, right? So the function is not continuous at x equals 2. There is jump discontinuity, right? Or you can say non-removable. Okay? Discontinuity at x equals 2. Okay? That's how I'm going to say. And then they are not equal, so that's the justification. They're not equal, then there's a jump discontinuity. Now, next one. Top one, when you factor x minus 2 and x plus 2 over x plus 2. That shows at x equals to negative 2, same factor, that's a whole. So this one, when you graph this piecewise function, when x is a negative 2, so basically you graph x minus 2. Okay, your graph looks like this. And then when x is a negative 2, is a negative 4. So basically there's a hole there, right? At x equals to negative 2, there's a hole. And also when x is negative 2, it's at 3. Right here. So you see that piecewise function graph like that. Then at x equals to negative 2, there's a discontinuity, right? Discontinuous. At x equals negative 2, the function has a hole, right? Which is removable discontinuity. Okay, and then proof is hole means a limit x equals to negative 2 from negative side, right? Then you have x minus 2 and x plus 2 over x plus 2. So after you cancel, you plug in negative 4, and also limit x equals to negative 2 from positive side. I'm going to copy this. X plus 2. So also this after you cancel, you plug it in. So negative 4. So as long as they are same, then that's you have a limit there, right? And it's a removable. It shows there's a hole. Okay, that's justification. Now let's move on to E. As you know, when you graph this one, we know that there's a vertical asymptote at x equals 3. So that's a vertical asymptote. Set denominator equals 0, solve for x, then x equals 3, right? That's a vertical asymptote. Your graph looks like this after you graph it. So you can say it's a not continuous, right? Not continuous at x equals 3 because the function has vertical asymptote at x equals 3, which is non-removable, right? Non-removable. Okay, that's a justification. I think that's enough to explain is continuous at that point or not continuous at that point. All right, now next one, let's go over a little bit about the derivative. So using power law, so f of prime of x, when you take a derivative, this one, 2x, right? Using power law. Negative any constants will be 0. So you have that. So what is f of prime of 2? So you plug it in. So 2 times 2 is a 4. That's the answer. Now find the equation of tangent at x equals 2. So you need to find the y value first. What is f of 2? So you use this one here. So 4 minus 9, which is negative 5. So what I'm going to do is a y minus y1. Slope, we got here 4. And x minus x1. So when you simplify and now you make it mx plus b format, y equals 4x minus 8 and minus 5. So y equals 4x minus 13 will be your final answer. That's the tangent line equation. Now, next one. So f prime of a. So we already know f prime of x is that. So f prime of a is a 2a. Okay, that's the answer. Now, number 16. f of x is a piecewise function like that. Determine the value of k for which f of x will be continuous. In order to be continuous, your left-hand side limit x approaches to 1 from negative side, kx squared plus 2. So when you plug in 1, that's k plus 2, right? And also when x approaches to 1 from positive side, you use this one, 6x minus k, and then you plug in 1 into x. That's a 6 minus k. They should be equal to be continuous, right? This one should be same to be continuous at x equals 1, right? So then k plus 2 equals 6 minus k. And then when you collect like term, 2k equals 4, so k is 2. That's your final answer. So in order to be continuous at x equals 1, k value must be 2. Okay? And then the last one. Let f of x is 2x squared plus 1 all over x squared minus 16. Find the equation of horizontal asymptote. You have to remember, to find out horizontal asymptote, you have to take the limit x approaches to infinite, and also you have to check x approaches to negative infinite both ways. So let's do that. 2x squared plus 1 over x squared minus 16. So horizontal asymptote, like we talk about it, same power, same exponent, numerator and denominator, then take the coefficient, right? So 2 over 1, which is 2. And this one, 2x squared plus 1 over x squared minus 16. So in this case, it doesn't matter. Negative infinite, positive infinite, both goes to positive infinite. So that means also 2 over 1, so 2. So you can say, what is a horizontal asymptote here? So y equals 2 is a horizontal asymptote. Okay, y equals 2. Now, they ask you, B, what is the equation for the vertical asymptote? Vertical asymptote is a set denominator equals 0. So x squared minus 16 equals 0. X minus 4, x plus 4 when you factor. So then x equals 4 or x equals negative 4. Those are vertical asymptote. Okay, you have two equations. How are you going to justify? This is justification of horizontal asymptote. Okay, that's how you're going to do. And then what is the vertical asymptote? Then you can say limit x approaches to 4. And then 2x squared plus 1 over x minus 4 and x plus 4. Right? So then numerator is not 0. That's 33 over 0. So which is infinite. Right? And then similar way, limit x approaches to negative 4 and 2x squared plus 1 over x minus 4 and x plus 4 again. So then denominator 0 and also top on 33 over 0. So that goes infinite, right? So when x approaches to 4 or negative 4, both approaches infinite, that means that shows that that's a vertical asymptote. Okay? That's the justification. Okay? All right. That's it for this video.